Hi, my name is Abdul Wahab Animoku and I'm a college maths instructor. So welcome to my YouTube channel. If you're new to this channel, please subscribe, like the videos and comment down below on what type of video you'd like to see from this channel. In today's video, we are going to talk about how to find the adjoint of a linear transformation. Okay, so let's just get started and get right into it. So what is an adjoint of a transformation? So this problem would be a learning curve for us to try to understand how to find the adjoint of a transformation in general. Okay, so what is an adjoint of a transformation, right? So let's say you have a transformation t, just like in this case, from r cubed to r cubed. Now, the adjoint of this transformation is also a transformation from r cubed to r cubed. In general, let's say you have from this vector space V to V, then T star will also be an endomorphic transformation from V to V. But then what's the relationship between T and T star? Now, now for this particular transformation, these vector spaces are equipped with an inner product. Right? So they are inner product spaces, right? And then the relationship between T and T star is this. The inner product of, so let's say we take, okay, so let's do it this way. Let's say we take a vector from V, right? Let's say A is a vector from V, right? So what happens, the relationship between T and T star is through this inner product. So if I find the inner product of A and then look at the transformation T star of another vector B. So B is also from V, right? So what happens is that the inner product should be equivalent to, if I find B, so let's do it this way. This will be equivalent to if I find T of A, and then we have B here. Okay, so this is the relationship between the transformation and its adjoint. Okay, so now let's see how this works for this particular problem. Okay, so we are going to look at the first method of solving this, which is using the inner product. In the next video, I would solve the same problem using a different method, which is a much easier approach compared to this. So what do we do here? So for example, we are taking a vector from this r cube. So that means let's take a vector A from r cube. Now, any vector in r cube should have three components, say x, y, z, right? Now, what we're trying to show now is we know that what, for us to find the adjoint of this transformation, we know that this vector, the inner product of this vector and the transformation T star, right, should be able to give us the transformation of x, y, z, the inner product of this and UVW. So this is what we have. Okay, now we are going to focus on this. So so the trick of solving this problem is to focus on this inner product, evaluate this inner product, and be able to see if you can rewrite that inner product as an inner product of this vector xyz, and then whatever we have on the other side would be the t star. Okay, so that's the trick. So let's go ahead and do this. So we already know what our t of xyz is. So let's quickly go back and look at it. So we know that what t of xyz is basically the first component is x plus y plus z, second component is x plus 2y plus 2z, and the third component is just x plus 2y plus 3z. Okay. Now this is the first. This is t of xyz. Now what about uvw? It's just a vector, another vector b from the vector space. Okay. So what's this inner product? We just said inner product. We know that inner product is just the sum of the product of each component, right? So this would give us the first component multiplied by the first component here, plus the second component of the first vector multiplied by the second component of the second vector, plus the third component of the first vector multiplied by the third component of the second vector. This is how we find inner product. So it's just this multiplied by this, plus this multiplied by this, plus this multiplied by this, basically. Now, the next trick we are going to use is to rewrite this sum as so now we know that we have factorized this sum in terms of u, v, w, right? So we put all the terms that have u in them in one bracket, and we have multiplied by u, the same thing multiplied by v, and then multiplied by w. Now we are going to rewrite this in terms of the all the terms that have x in them. So if I expand this, notice that what if I expand the first component, I will have xu plus yu plus zu. The second component, I will have xv plus 2yv plus 2zv. The third component, the third term rather, I would have xw plus 2yw plus 3zw. Now let's just focus on the terms that have x, right? Which means this. Now, if I factorize this together, that will mean that what x, I can take x out and I have u plus v plus w. The same thing for y. I can now focus on this. Now take y out. That would give us what? U plus v plus u plus 2v plus 2w. And finally, if I take z out, that would give me u plus 2v plus 3w. Okay, so this is what I have. So now the trick here again is to rewrite this as an inner product. As you can see, it's just product of this vector, inner product of this vector x, y, z with whatever is inside the bracket, right? Just similar to what we have in this line. Okay, so this can now be written as what? Inner product of x, y, z with this vector u plus v plus w. We have u plus 2v plus 2w, and then lastly we have u plus 2v plus 3w. Okay, so this is what we have. So basically, as you can see, this can now be written as what? So now when we compare, so remember that what we have on the left hand side is this. So this gives us an idea that this vector here that we have on the second vector that we have, oh, I think there's a mistake here. So let me just correct this. This is just the second component is the third component, so it's just the same vector, one vector. So 2v plus 3w, right? So if you compare, you can just see that what the t star, which is the adjoint transformation, is just what? This. Right? So t star is the transformation from arrow cube to arrow cube such that t is given by this. So this is the adjoint transformation. Now notice something, that the adjoint transformation is just exactly the same thing as t, right? If you check x plus y plus z, this is u plus v plus w, x plus 2y plus 2z, the same thing, u plus 2v plus 2w, and so on and so forth, right? So you observe that t star is equal to t. They are the same, it's just the same transformation. So when this happens, we call this t as what? T is self-adjoint. So this is how we name this. So whenever the transformation t is equal to t star, we can conclude that that transformation is self-adjoint. Okay. Now this is a learning curve on this particular problem. Like I said, I'm going to show you a different way of solving this same problem in the next video. So if you haven't subscribed, make sure that you subscribe to this channel so that the channel can grow. And then as well, I would expect you to see your comments down below if you have any particular request, any particular problem that you would want me to look at, please send it my way. And my email address um, is is in the description down below. And also the link to the previous videos are also there. There's a playlist with problems on linear transformation. Make sure you watch all the videos on that playlist to advance your knowledge on linear algebra. So thank you very much. I'll see you in the next video.